Hello, in this video we're going to do one more example using the inversion formula, going from a characteristic function to a PDF. So let's jump right in. Let x be a random variable with moment generating function m of t defined like this. T is real, alpha is real, beta is greater than 0. Find the characteristic function of x. Find the PDF of x, and find the fourth moment of x. Okay. Well, the first piece, find the characteristic function, is pretty straightforward. Since we know the moment generating function, we can evaluate the moment generating function at I of t, it. So that means stick in an it wherever there's a t. So it becomes this and this. Now with the I, we get I squared, which is -1. That's why that sign changed there. So now let's find the PDF of this. And the inversion formula says, take the characteristic function, multiply it by this here, integrate, and then divide by 2 pi. And we get back our PDF. So let's do that. First, let's combine the e here, and we get this. So I factored out a beta in front, which means I have to, we get beta squared, and then have to divide by beta for this. You can do that on your own. Now the reason I do that is I want to complete the square with t, and this is just my preference. I don't like to have a coefficient in front of the square term when I complete the square, so that's why I factored it out. So now you complete the square, and I get this. So we're taking the squared, and then what's left over is this piece here. And the reason we do that is this is starting to kind of look normal like over here, which would then integrate to 1. So we have to do some further manipulations here. So this piece here, the squared, so it's t minus something squared. So that kind of looks like the top part of a normal. But we need the -2 sigma squared down here, or 2 times the variance. So what I do is I take this b down, which is this, and then I have to multiply and divide by 2, so to kind of get the 2 out front. So this looks like the variance, and this looks like the mean. Okay, but to have the variance, I have to take the square root of it over here, which then, of course, you invert and multiply. But if I take it times here, I have to divide here. And then so this piece, that I just take the square root, split it. Well, now this is a normal distribution. Mean this, variance that, and it integrates to 1 and goes away. So we're left with this piece out here. So what we can do is, if we look at this looks like a normal. So it's x minus something squared minus 2 times, I'm going to call it the variance. Well, it is. Then you divide by the 2 square root of 2 pi, and then divide by the standard deviation, which means the square root of 2 beta. So that's a normal alpha beta. So now let's find the fourth moment of this. And there's 2 ways to do it. One, we could find it directly from this distribution, which we'll do. And then we can find it using the characteristic function. And so we'll do it both ways. So first I want to standardize x to a standard normal. So minus the mean divided by the standard deviation. And then and I have a video out called finding the first 4 moments of a standard normal distribution. And I use various 2 or 3 different ways to how to do this. So the first moment, the mean is 0, which of course we knew. The x squared is 1, which ends up being the variance when the mean is 0, so we knew that. Every odd moment is 0 in a standard normal, and the fourth moment is 3. Now we're going to come back to these in a second. So we have x to the fourth. Now if we substitute in our transformation or back solve for x, we get this. And then when we expand this is a binomial expansion, we get this. So it's the sum from 0 to 4 of 4 choose k, and then the alpha is this piece, and then this is that piece, and it goes, and then it's 4 minus k. So then to expand it, we get this, and then expectation is a linear operator, so we can take it inside. But notice that the expected value of z is 0, so this term will go away, and the expected value of the third moment is 0, so that'll go away. So we have x to the fourth, alpha to the fourth, and then expected value of z squared is 1, so we just have the constants out here. And then this is 3, so we have 3 times this constant, and we're done. That's the fourth moment. So now let's use the characteristic function to find the fourth moment, and that says we need to take the fourth derivative of the characteristic function with respect to t. And it was somewhat tedious, and so I did not provide every step, but this is what I came up with in the end. Now we need to evaluate this at 0. T equals 0 for the fourth moment. And I probably should have put the expected value of x to the fourth is equal to this. So now it says plug in 0 for t. So we get 0 there. So we just get ai to the fourth. 0, 0, so that's 1, goes away. Plug in 0, so we get minus 12b ai squared, and then that's 1, and then that's 1, so we get 12b squared. Now this doesn't look anything like the fourth moment, but we have to change this. What it ends up is if we have I to the fourth out front, and then whatever's over here is going to be the fourth moment. So what I want to do is factor out an x to the fourth everywhere. So here that just comes straight out. Now this is I squared, so to factor out I to the fourth we have to divide by I squared, and there's no I here, so we just divide by I to the fourth. So if we multiply that back in, we get this, and I squared is minus 1, so we're dividing by minus 1, so that's essentially going to change the plus sign. I to the fourth is 1, so it doesn't affect it, and we end up with this. And now that says that this piece is the fourth moment. And if you look back to what we did, it's exactly the fourth moment. So this is 12, this fourth, 3 is 12, the fourth, it's the same thing. So anyway, so that's two different ways to find the fourth moment of x. Well, that's the last little piece of the inversion formula that I'm going to do in this little mini series. I have I think 2 more videos that I'm going to put out in regards to factorial moments, characteristic moment generating functions, and etc. So hope you liked it. If you did, please like the video and subscribe so you don't miss the next one. Thanks. Bye.